Other one, January 13th. Let's do it. Find the prefix common array of two arrays. We're given two arrays. Integer permutation AB and then length of length n. A prefix common array of A and B as an array C such that Ci is equal to the count of numbers that are present at or before the index I in both A and B. Return a prefix common array. Okay, so the prefix common array, so Ci, so C0 is equal to the count of numbers that are present at or before index. No number is common, so count of common numbers, right? I think I'm missing a word here. Yeah, so at this point is nothing. At 1 we have 2, yes. At 2 we have 3, and as before. Makes sense, right? If we go with 1, 2, 1, 3, 2, 4. 3, 1, 2, 4. So the common ones is 0. The common ones are here. So basically we need to know what is... Well, we can create two sets. Common. That means it exists in this and it also exists in this, right? Yeah, we can do an intersection, like a set on here, a set on here, and then we just do the intersection. Probably not the most efficient way to do this. But look at the n. N is only 50. So technically speaking, I can just go 50. 50, you say. And it's permutation. Both are permutation of n integers. And you say the length is smaller or equal to 50. Can we have duplications? I bet we can. I bet we can have duplication. Oh, to have different values. He didn't say they all have different values though. 209 permutation of length n. A sequence of n integer. Oh, it says if it contains all integers from 1 to n. Oh, okay, yeah. So I'm thinking about bit manipulation because it's only 50, right? I can do a long. Long is 64 bit, right? So I can just set them. Each one, I set the bits, right? So in this case, we have 4 bits for A and then 4 bits for B. So 1, well, we can just do -1. So basically we set this as a 1. All right, 1, 2, 3. So this is a 1. And then we have all the 2, which give us 0. Next, we'll set this bit, all these 2, and then we'll count the number of set bits. So it'll be 2 set bits. Let me see if it's possible. Long mask. Mask, left shift. Wait, hold on. Will be mask equal to mask or 1 left shift, I don't know, 50. This is allowed. Yeah, I probably need to remove the test case. This is allowed because it's a long. Oh! Or press the wrong button. Press the wrong button, now we submit it. Okay, that's not right. Oh, we need to say long 1. Yep, that will do. Okay. Long mask. Long 1 bit. We basically say, oh, we need 2 masks. Mask A and mask B. Okay, and then we say mask A or equal to 1 left shift AI mask B or equal to A and BI. And where's our rest? Rest I'll push back. Okay, how do I count number of bits? Built-in pop count. Oh, interesting. Bit set. probably use this. Oh, there's no one. Use bit mask to keep track of what number has appeared in A and B. The end of the two bit masks show the common, right? The common numbers. Call it ON. Ooh, is not right. Interesting. How? I'm missing one basically for every single one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Number 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It doesn't look anything special. 32. Huh. Do I have a C++ playground? Well, for one, I want to say bit set. Just kind of see how it's used. Position T. Hold a second, I just want a playground. Okay. So what I want is, okay. Actually, hold on. Bit left shift 32. Yeah, it looks looks okay. Yeah, it looks okay. Why it's not right? Sorry. Print bits. Yep, I think we use bit set. Okay, so I just want to see the bit set, right? So the std cout bit set. $50. Mask A. Alright, let's see what went wrong. It looks good to me. Maybe we should do another one. Current. I don't understand. It is 32. In an unsigned integer. So it cannot count more than 31. Oh, it has to be an int. Having to type long. Yep, I was like, my method is good. Why it didn't work? Note, have to use. Awesome. Yeah. I have full confidence in you.
What?
Yeah, tomorrow. You're gonna do great. Ooh!
Ask me a bunch of last minute questions. I'm worried about tomorrow morning maybe.
Oh, be prepared. I think they probably will.
Maybe I shouldn't train in the morning.
Nah, I think you just keep doing your routine. Your routine of however you're doing it right now.
I don't have time to work out if I wake up at 6. Yeah. Do it.
Okay, we're done with this. A little bit interesting thing about C++. Pop count, LL, is the handle long. Yeah, we have to use long in this one. Alright, so we're done with this. Good. Alright, so we have an idea for this yesterday, so let's try it. Honestly, I forgot what the idea was. Okay, so it's a subsequence. So the ideal is we'll use DPI, right, to find the longest length of subsequence ending at nums I. So for nums I plus 1, okay, for nums I plus 1, what we do is you grab the number. Oh, and it's not the length, but also the difference. So you have the length and the absolute difference. So we have two things, the length and absolute difference that's ending at here. So now you grab your nums I plus 1, okay? Then you can say, oh, we don't need a difference. No, because given a number, the difference we can go is just a 0. Right, you can do difference 0, 1, 2, all the way to the current number minus 1. Now for each one, you will find just going to, because we have 300, so you will find the last index of the occurrence of that number. Wait, hold on. Hold on. What are we saying? Are we saying because it has to be decreasing, right? So if you say we want index, but for each number you have to go through all of them, right? The difference is 0, the difference is 1, the difference is 2. So you find, the delta, right? So you find nums I plus 1 plus delta in a previous right? Enjoy. And you find nums I plus 1 minus delta if it's possible. But it can be also smaller than that. But we don't really care. All we care is if the difference is D, then I have this number. So in the array, right, we're going to find this number in the array where it was, because this is the number that I can fit my current. And that number might appear in multiple places. Yep, it might appear in multiple places. And we do need its absolute difference. We do need its absolute difference, right? We need its absolute difference when it reaches the maximum length, because I'm trying to go for this number. I need to know if this difference is smaller or equal to that difference. Ooh, this seems to be more complicated than you had thought yesterday. Because yesterday what I thought was, I have a list of all the occurrences, 1, 2, 3, 4, 5, and I have its indices. They occur at this position, this position, this position. They occur at these positions. And now I say I want to have my current number to match to my previous should be this one, because the absolute difference is certain value. Then I need to know the absolute difference for this, this, and this. And I need to know if my current is smaller. Yeah, that doesn't look right. I think we have to still do dpij. Maybe it was dpij initially. I don't know why I didn't do dpij. Yeah, I think it's dpij. I think yesterday was dpij, right? Yeah, yesterday was dpij. I don't know why I didn't say dpij. Yeah, it's dpij, which is the max length, right, ending at nums I with j absolute difference. right? Now I need to do dpi plus 1. Now this j is going to be 0, because absolutely can be 0, all the way to the max, because what we're looking for is going to be the max minus minimum, right? So the max minus minimum, that's the max you can get. We don't have to go all 300, right? This is the max minus minimum. Now for dpi plus 1, 0, right? We should be ending at I plus 1. We're going to find 0, right? We're going to find 0 difference. And then we can say the previous one I need to look at is I plus 1 plus 0. We can call it k, right? We can call this k. So just plus k and nums I plus 1 minus k if possible. And then for that number, I need to know where in the dp. Yeah, we're in the dp. Huh. And this is I is index. I'm saying I will use the latest index. I'll go to the latest index, because if you go to the latest index for that number, you always have a higher chance of getting a bigger subsequence, a longer subsequence. That is my belief. Okay, we can try this idea. Alright, so this idea will be right? This minus 1. Hold a second. What do I hold? The length. Right, so the length, I think 0 is fine. Times j shall be high minus low plus 1 for this range nums. Right, so that's our dp. And I'll have last indices. High plus 1. Right, this is the last indices. Now we're going to go through them one by one. So say for I range okay, so for the first one, maybe the first one, I don't even, for the first one element. The sequence is always 1, right? Actually, I'm not sure. Can we have... Oh, length at least is 2. Okay, length is at least 2. So... length is at least 2, which means at position 1, right? At position 1, I can go through all the differences that I can create. Right, all the difference I can create. And hold on, let me think again. In a position 2, right, I go through all the difference I can create. For each difference, I find the previous and see if it's available, right? And one of them will be available, and that one will say the length is 1. That one will say the length is 1, right? That one will say the length is 1. At any difference, the length will be 1. Because the second one, it will always be length 2, right? 2 of them will always be length 2. Because there's nothing to compare them to. Okay, so what I'm saying is it will always be length 1, which means we can say dp is 0. I don't know, how do I fill? Python should be fill everybody's length 1. Ah, screw you. Ooh, let's call it J. They will call this edge cases. Okay, from 1 to the end, but J in range 0 to maximum is gonna be high minus low. Right. So for 2 possibilities. Previous subsequence value bigger than nums I. Right. So pre shall equal to nums I plus j. Right, nums I plus j. And then we can say if last indices pre is larger or equal to 0. Right, so the last index is larger than 0. That means we have it. And then we can go to, we can call it, let's call it k equal to last. Oh, isn't this, we can use k, this Walrus. Right, so we say k is the last indices. And then we go to dp k, right? dp k, and the current difference is j. So, do we need to check for all the differences? As it has, it can only be bigger difference, right? It can only be bigger difference. Hold a second, it can only be bigger difference, right? So what we're saying is dpi, so the difference is 0, right? And now we have dpi1, the difference is 1, which is basically here, if the previous difference is 0, what's the largest? If the difference is 1, what's the largest? Right? And when you have difference is 0, you have more access to previous. Because imagine if you say dpi, the difference is 300, there'll be nothing, right? Nobody can really support it. You need to find someone that's, has difference is 300 for you. Otherwise, you're not gonna have it. So it does seem like it should get bigger and bigger as you go down. Or should I say, when you do a difference, when you do a difference, and then you go to a lower level, the lower level should always give you a bigger result. Is that true? The lower level always give you a bigger result. Because I'm currently a 0. Right? I'm currently at a certain j. And I look for, because I'm doing this j thing, right? I'm doing this j thing. I'm doing this j thing, right? And I'm saying I want exactly j. The difference is exactly j. So I minus j, I plus j, I find the value, right? And from that value, I can only go with the difference is also j or bigger, right? The difference is j or bigger. So what I need is from this towards the end, what is the biggest? Which means the dpi needs to be a suffix max. So we need to go from right to left, suffix max. Every time we do, we need to get the maximum value, right? And then when I need to query, then I get a maximum value. Okay, so instead of going here, we need to go from, this is the maximum difference, minus 1, minus 1. Is the longest subsequence length ending at nums I with absolute difference not smaller than j. Okay, previous subsequence bigger than j. If we can find it, right, now we say dp, this is not right, this should be I. Oh no, wait, this is the index, right? So dpk j plus 1, right? So basically say dp I j shall equal to maximum. This is to look at the previous j towards the end, what's the maximum, plus 1, and dpi j plus 1. Of course, it's if we have j plus 1. If j is smaller than high minus low, else just 0. Which means if I added the maximum, If you add a maximum, you shouldn't even do this. But let's just put it there. Maybe we don't even need this if condition. All right, because if pre this plus j yeah, it might not actually exist. So if pre is smaller than len high plus 1 high, and so pre, oh, I probably couldn't do it this way. Alright, I'll say k equals to last indices pre, right? If pre is less than high and this, then we have a k, right? And then, which means j is not too big. Because j smaller than high minus low. So the high minus low is the maximum j, the maximum difference. And if it's a maximum difference, if it's a low, then it's still possible, right? So I still need to know, towards the right what it is. We don't know, right? So we get a current. Okay. And then we say previous subsequence value smaller than nums I. Now we say if and then pre equal to nums I minus j, right? If pre is larger than 0 and last indices pre is larger equal to 0, k equals last indices pre dp I j equal to maximum. Probably need to say dpij as well here. I can do this, right? Yeah. dpij dpkj plus 1 and dpj plus 1 if j is sort of high minus low, else 0. So these two are exactly the same. Maybe want to write a function about it. All that's different is the pre. Def update. So we just need a DP, right? So which is a list of int. We update DP and we need the last indices. List of int, and we don't return anything because we are update in place. So we just give a pre, right? We give a pre, and pre is int, right? So we say if 0 smaller than pre smaller than high. Oh, we need a high. Damn it, high. Right, and last indices. Jesus. Indices. Last indices pre is larger equal to 0. K equals to this. dpi equals, oh, I need high and low. Right, high and low. J is not defined. God Lord. So in the I, J, what else? Okay. So in this case, we can say update self.update self dot update nums I plus j, low, high, dp, and last indices. And here the same self dot update nums I minus j, low, high, dp, last indices. Right? And then we should also have we also have a res is equal to 0. So every time once I handle this, res shall equal to maximum res and dpij. So grab the current largest. And once we're done, we return res. Okay, it's very crude, so I do not have very high hope that this will work. We'll give it a shot. See if it... Nope, it doesn't work. Okay, that's all right. I mean, I don't really think it will work because I feel as I'm doing it, things just not really clicking very well. So we'll deal with this. What do we have? This is this. Okay, what's the answer for this? Answer is 3. Right, and this is the longest. This, and then we'll have nums. Okay. Let's put this one here. F5. All right, let's debug this thing and see how it goes. Anyway, so the dp is 3, yes, and the difference is 13. The maximum is 13, and the first one I set to 1. That's correct. Last index. Oh, you did check last index. Okay, that's probably why. Last index. So, oof. So we'll do this. Once I finish going through everything, we should say last indices nums I go to I. That's the last index. Okay, we'll just add this line. You know what? Let's rerun the whole thing. Maybe if we rerun the whole thing, things will be different. Or slightly. Okay, we got some result, but still not good enough. Okay, let's run it again. Oh, 5, 1. Okay. So I think the setting is good. I have DP, we have last indices, except for 16 is 0. That's correct. DP is good. Okay. Len is 3, high. Doesn't matter. So I is going to be 1. J gonna start with 13. Right, J start with 13. Then self update. Nums I is 6. 6 plus 3. Oh no, 6 plus. It's nothing, right? We don't update anything because right now it's 13. 6 plus 13 is 19. Is no good. 6 minus 13 is also no good. So basically we don't do anything. Rest remain. Oh, rest should be, yeah, that's fine. And next is 12. 12 still, we have nothing happening, right? 12. 3 plus 12. Wait, hold a second. Hold a second. That's not right. That's not right. Hold on, hold on, hold on. Right. Okay. Can I step into? Is this step into? Is F1 step into? Yep. Alright, we step into. Where is my pre? Pre is 19. Okay, pre is 19 is probably not gonna be good. So we'll jump out. Next, pre is -7. Oh yeah, this is 10. My bad, this is 10. Okay, that's fine, that's fine. So we need to wait until 10. So 12, 1, 10. So now it's 10. So this 6 plus 10. Okay, so pre is 16. Last index 16 is 0. So k is 0. So you look at dp 0, right? dp 0, j is 10. Doesn't matter, this will be 1. So this will be 2, right? This will be 2. And plus 1. dpi j plus 1. I don't have. Right? So we do F1 here. Come in. What? That is bonkers. Wait, what? Hold on. Yes, pre is 16. Oh, smaller or equal to high. God, Lord. That shall be smaller, because this is, yeah, it should be smaller or equal to high. A 0 we cannot reach. Right, we cannot have 0, but it should be smaller or equal to high. Oh my god. Okay, one of them is right, the other two is not. Okay, we debug again. Alright, so this one shall have dp1 16, not 16, 13. Shall give me 1. Give 2. 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. This shall skip. So rest now become, where's rest? Rest now is 2. Okay. And all the others just nothing. Right, all the others nothing. 5, 3, 2, 1. Done. 0, okay. Get out. So last index of 6 become 1. So if you check last index, yeah, 6 become 1. Alright, so the next I2, so it's 3. Okay, so we start from 13. J is 13. 13, yes. because it's 16. So we go to 16. So we got 2. Right? We got 2, which means we go to 3, we go to 6. Right? If we go yes, yes, and then basically 3, 13 will become 2. Yes, 3, 13 become 2. This one's bad. Let's do 2. So now what we're looking for is 3. So we go all the way down to 3. Alright, now it's 3. Pre is 6. K should be 1. Right? K is 1. So we do dp 1. Oh, dp1. I see what is wrong. I see what is wrong. It has to be a suffix max, but you're not doing a suffix max. You basically get the dp value, right? You get the value and you do that, but you also need to say I think that's fine. So we have the dp value. So if you don't do it, then you should do I see. Hold on. I think I'm gonna change some stuff. So basically this is a get option 1. This is a get option 2. Right? I'm gonna get a maximum of option 1 and option 2. And a max of what we can get so far. And put that in. Okay. Then why do I need this? Right? Then why do I need this? And I guess it's fine. So we'll return dp k j plus 1. Otherwise we'll return 0. Okay. We don't need this. And this is gonna be int. This is not needed. I is not needed. J is needed. Okay, I is not needed. J is needed. Okay, I is not needed. J is needed. So I will delete I, and then we'll delete low. Okay, and then we'll call this op1, option 1, option 2, right? Then we say dpij shall equal to maximum option 1, option 2, and dp I j plus 1 if j is smaller than high minus low, else 0. Yeah. Okay, let's check this. Wow, it has been 1 hour. I didn't even notice. It has been 1 hour. There we go. This one looks right. Use dp, where, of course, I'm not sure if it's really correct, but long solution length ending at, right? Is the note that essentially DPI is a suffix max of longest subsequence length, where dpij is the max of all dpij towards the end. When a new nums I plus 1 is considered, where we go through all possible diffs, right? For each diff, we have the target number nums I plus 1 minus j, or nums I plus 1 plus j. We find the latest indices of these target numbers and query the longest subsequent length ending at that number, ending at the target number with absolute diff not smaller than j. We can use the latest index because it should always offer a longer subsequence. Now, not should, it will, because it always offers a longer subsequence than an earlier index with the same number. Ooh, so mn, let's see. It'll be great if it just pass, but if it doesn't pass, that's also fine because we'll just handle it tomorrow. Okay, putting some pretty random stuff and then see if it works. Oh shoot, it does not work. Oh god. Oh lord, it does not work. Okay, can we conjure something less complex? Maybe we remove half of it. Hopefully it still doesn't work. Then we have a test case to work on. Gosh, it works. God damn. It's okay, let's remove the first half. Oh, we shouldn't actually remove. We should just... Oh my lord. Both worked. Okay, how about remove something in the middle? Does that give us a wrong case? Yes. Okay, this we can work on. Alright, this we can work on. And we'll work on this. Output 7. No. Output 4. Answer should be 5. Answer should be 5. I wonder if we can make it even smaller. Maybe I remove some stuff. That might be too small. Nice. Nice. Yeah, I can immediately see 42, no. This is 33. The 2 is 33. So 65, 32, and 2. Right? So ending at this 2, we shall be able to find 3, but only find 2. Great. Great test case. We'll deal with this tomorrow. Alright, I'll see you guys tomorrow. Adios.